As we talk about circles, it is worth reminding ourselves of the names of different parts of a circle. This length here from the center to the edge is called a radius. This line that goes all the way across the circle through the center is a diameter. This point in the middle, we've said it several times already, is the center. This length that goes all the way around the outside is the circumference. A line here that just touches the circle at some point is called a tangent. A part of the circumference is called an arc. The bit bound by an arc and two radii is called a sector. Looks a little bit like a piece of pizza. A line that goes from the circumference all the way across, but not through the center, is known as a chord. And finally, the area bounded by the circumference and a chord is called a segment. Looks a little bit like a piece of orange. So those are some words we use when we're talking about circles. Now, when we're talking about arcs and sectors in particular and finding the arc length and the area, we have two results depending on whether we are in degrees or radians. In degrees, which is considered to be prior knowledge for this course, it is whatever the angle is. Let's call the angle theta. It is theta divided by 360 times by the circumference, which is 2 pi r or pi d. This is when we're in degrees, so I'll add degrees there and there. The area of the sector is theta degrees over 360 degrees times by the area, which is pi r squared. When we're in radians, and this angle here is theta radians, and this length here is r for the radius, then we have a formula we can work out as well. And it's actually the same, but it's going to be over 2 pi. So it's theta over, instead of 360 degrees, 2 pi radians, times by 2 pi r. But what we get here is that some things cancel. This 2 pi cancels with this 2 pi, and we get left with a much simpler formula, which is just theta times r, or in the formula booklet, it's r theta. Similarly, for the area of the sector, we have theta over 2 pi times by pi r squared, and again some things cancel, the pi's cancel, and we get left with a half times theta r squared, a much simpler formula that doesn't involve those pi's and all those fractions. You are given these two in the formula booklet, and within this course, expect that you'll be working in radians when calculating arc lengths and sectors, not in degrees.